Chapter Review 1, problem number 10. So it's this one. I want you to read the full problem 1, 2, 3, 4, as many times as you need, and let's start. So a tank contains 55 liters of water. Okay, that's the initial amount. Water flows at a rate of 7% per minute of the previous quantity, guys. Okay, you should understand that. Like this 7% is always taken from the actual amount of water in the tank. Okay, this 7% will not be applied to 55 all the time. You're gonna understand what I mean in a moment. So let's go over the 5 questions. Write a sequence that represents the volume left in the tank after 1 minute, 2 minutes, 3 minutes, etc. So basically, guys, they want me to find a, a sequence that represents the volume of water in the tank after 1 minute of being open, you see, after 2 minutes, and so on. So I'm gonna represent that. I'm gonna write this Vn, right? And I'm gonna say that this is the volume of water in the tank. You see how precise I am? Like I make my variable very explicit. The volume of water in the tank after, that's a very important word, after n minutes of being open. N minutes of being open. Okay, I'm being very strict with my variable, and I'm defining it very clearly. So now let's see. So initially there are 55 liters per water. That's at minute 0. I'm gonna do this at minute 0, at minute 1, at minute 2, at minute 3, and so on. So at time 0, I have 55 liters. I'm not gonna write the unit, right? We're talking about liters, so there you go, 55. And then after 1 minute, from 0 to 1, this is after 1 minute, how many liters of water will we have? Well, will we have 55 liters, which it was the initial amount, minus the 7% of 55, which is going to be this, minus 55 times 0.07. Okay, in other words, you can actually see it this way, or you can see it in a more simple way, just 55 times 0.93, right? Because if through this minute 7% of this quantity has left the tank, then how much remains? It remains this much, right? It remains the 93% of 55, and that's a better way to look at it. So that the volume at time 1 should be 55 times 93% of this original 55, and then another minute goes by. Okay, and then we know that this was the previous amount of water in the tank, and now 7% of this has left the tank, and therefore only 93% of this quantity is going to be here at time 2. So I'm going to take all the quantity, there you go, and I'm going to multiply it by 0.93. You see? And what is this equal to? This is the same number, so I can write it as a square. 55 times 0.93 to the square. Like so. Okay? And then I guess you're seeing already the pattern, right? Basically, we will always, in every successive term, basically what we have to do is keep increasing the exponent in this 0.93. So in here it's going to be like this, and so on. 1, at minute 1, this is 1, at minute 2, this is 2, at minute 3, this is 3. So at minute n, we're going to have this. This will be the amount of water in the tank, this much. So that's it. I have found my sequence. This is the sequence. And actually, I have written already. Let me make a division over here. I already know what the general term of the sequence will be. So I have found this. The volume in the tank after n minutes of being open will be equal to 55 times 0.93 to the n. That's what this symbol means. And we have solved A. B. What kind of sequence did you write? Justify your answer. It's a I'm not gonna write down, just listen. It's a geometric sequence because between every pair of consecutive terms, there is a ratio of 0.93. This times 0.93 is this. This times 0.93 is this, and so on. So that would be your justification. Done and done. C. How much water is left in the tank after 10 minutes? Okay, we're gonna use this one, right? Remember, what is this? What is this formula? It is the volume of the in the volume of water in the tank that is left at n minutes. After n minutes of being open. So I'm just gonna use it. If I want to know how much water remains at minute n, then I use this formula. How much water is left in the tank after 10 minutes? Then I just put n equals 10. That's it. Okay, problem solved. You can either leave this like so, or you can calculate it. Doesn't matter. Then let's go for D. Okay, let's see. D says how much water has been drained after 15 minutes. How much water has been drained after 15 minutes? Do not get confused, guys. They are not asking you for this. They're not asking you for the volume of water that is left after 15 minutes. They tell you about how much has been drained. Okay? So basically, what you have to do is this. You have to subtract from the original quantity. If you subtract the original quantity, which was 55, minus the volume of water in the tank after 15 minutes of being open, which is well, let me do the substitution. 55 times 0.93 to the 15. Okay, if you do this operation, 15 minus this much, then you will obtain how much water has been drained. You need to read very carefully and try not to be too rushed in your answers, right? Try to double think everything. And E, how long will it take to drain the tank? Okay, this is a tricky question, guys. And let me think of the best way to answer this. I'm gonna make a pause and I'll come back with you in a moment. Okay, class, so in this one, in exercise E, what you can do is the following. You must realize this, something very important here. The question is, how long will it take to drain the tank? You should know that technically speaking, and I mean mathematically speaking, there will always be some water in the tank, right? Like at first you got this much, and then a little less, and then a little less. But since this is a geometric sequence, there will always remain a little bit, a little bit, a little bit in all the previous ones, right? Like from here to here, there's only a difference of 7%, etc. So I think that a good way to answer this question is to basically do the following. You cannot solve this problem. Look, you cannot solve the problem directly. If you ask yourself, at what minute, if you ask yourself this question, at what minute is the volume in the tank equal to 0? Okay, So if you try to use this formula, you're gonna fail because you want to find at what minute this is 0. So let's substitute like this, okay? You want the volume in the tank to be 0. And this is an impossible equation to solve. This cannot be solved because this number can never be 0 and this is not 0, right? So the multiplication of these two numbers will never be equal to 0. The thing you can do though is specify, like if you encounter this type of problem in the paper, you would say, I'm gonna consider that an amount of, let's say, I mean, we're talking about liters, right? That was the original quantity, 55 liters, that's the unit. And let's consider 1,000 of a milliliter. 1,000 of a milliliter. So we're talking about 1,000 or of 1,000 of a liter, right? If we consider this 1,000 of a milliliter, and if we say if I look for this quantity, at what time there is this much water in the tank, so it would be like this: 55 times 0.93 to the n equals 0. That would be 0.000001. Okay, this is 1,000 of a milliliter, or 1,000 of 1,000 of a liter. This much. And I mean, you can write it down in scientific notation, right? You can write it as 1 times 10 to the minus 6, like so. Okay, so this is such a small amount of quantity, guys, of water, 1,000 of a milliliter. It's basically nothing. So that for all intents and purposes, and you should write that down, for all intents and purposes, for all intents and purposes, uh, um, we can say, for all intents and purposes, we can say that such a quantity is 0. This quantity right there. You see? But you have to explain that, guys. You have to make your reader understand what you're doing. Okay? If you write all of this stuff, and now you have this equation. This equals to 1 times 10 to the minus 6. I'm gonna do it. I'm gonna write it in blue in here. 55 times 0.93 to the n equals 1 times 10 to the minus 6. Then this equation is solvable, and we can solve it, right? So let's start. 0.93 to the n equals, this fraction, keep everything in closed form, in perfect form, like this. Don't compute anything yet. And then we have an exponential equation, and as always, we have its corresponding logarithmic equation. So that would be logarithm base 0.93 of this fraction equals n. That's how you find n, the minute at which you get this much water in the tank. Basically nothing, basically 0. And so if you argue this way, your answer is gonna be in 99% correct. You know what I mean? So all you have to do is compute. I mean, once again, you can leave it like this, or if you wanna compute this in the TI, let's actually use the TI to compute this number and see how many minutes will n be. So let's go to the structure for logarithm. It's right here. Logarithm base blank of blank, and and we have a fraction in here, right? So let's go to the structure of fraction. It is control, and then right here, Okay, and then I'm gonna write 1 times 10 to the minus 6. How do you do that? It's 1 times 10 to the minus 6. And here we have a 55. That's it. Enter. And we have an answer of 245 minutes. At 245 minutes, after we open the tank, there is 1,000 of a milliliter. Just think of how tiny is a milliliter, and then divide that by 1,000. Okay, so for all intents and purposes, like I repeat, for all what I wrote in here, for all intents and purposes, after this many minutes, there is practically zero water in the tank, and that should be a perfectly good and reasonable answer. I don't know where the book got this answer from. I cannot. I don't know. I just don't know. Okay, I'm gonna think a little bit about this, but I hope you understood what I did, and that is a perfectly good reasoning. Perfectly good reasoning.